All right, so today we're going to look at section 7.4, which basically uses all the properties that we learned Monday and Tuesday to solve equations. So the kind of things you want to remember for this section, how to write something in log form and change it to exponential, or the other way. If it's in exponential, change to log. Combining and splitting logs will come up. Okay, so we'll have an example kind of like, well, I'll find one, but we have one where we do have to combine and split logs. What else? Those properties that we talked about, you're allowed to put an exponent in front. Okay, that might come up a little bit today. And the change of base formula. Okay, so using a calculator to evaluate logs that don't have a base 10 or an e. All right, so let's start with this one. So this equation says 2 log base 5 of x equals log base 5 of 9. So the goal, because you have an equal sign, is to make sure that what's on the right looks exactly the same as what's on the left. Right now, part of it looks the same. Okay? They both have a base 5 log, but the arguments are different. One's an x, one's a 9. So on the right-hand side, there's not really much you can do. There's no numbers in front of the log on the right. 9 is just a single number by itself. So it's not like you can split or combine that. It's just a 9. But on the left, there is something you can do. Does anyone see what you could do on the left? Yep.
You put 2 in the exponent of x.
Yeah, that's about all you can do. And if at this point you're like, well, what's that going to do? Well, just do it, and then we'll look at it from there. So let's put the 2 back as an exponent. Now, there's really nothing else you can do on the left-hand side. And there's nothing else you can really do on the right-hand side. So at this step, we just kind of have to look at it and say, all right, that part already matches that part. Somehow we have to make this part match that part. So what could you pick for x so that when you plug it in, the left-hand side and the right-hand side would come out exactly the same? Yep. 3. And that's it. So it's not really a problem where you're getting x by itself to solve it. You're just kind of doing what you can, which was just one step, and then just looking at it and being like, okay, how do I make that match that? You're basically figuring this. How do you make x squared equal 9? You let x equal 3. Okay. Any questions on that side?
What if we scroll up?
Scroll up. Okay, so that's the first type. Pretty straightforward. Not really a lot of rules that we used except putting the number back as an exponent. But there was no combining. There was no splitting. You didn't have to change to exponential form. You didn't have to do any of that. Okay? That's all you had to do. All right, let's look at this one. So this one says log base 4 of x plus 3 plus another log base 4, this time of 2 minus x equals 1. Now, this one's a little different because we have multiple logs with the same base on the same side. What do you think we want to do with those 2 logs? Since they have the same base and they're on the same side, what can we do with them? Yeah, we can combine them. Okay, when you have multiple logs on the same side, you want to combine them into one. When I combine them, what's going to be the base when they're put together as one log? Yeah.
It stays 4.
It stays 4. When you combine and separate things, the base never changes. It's going to stay as 4. And now we have to look at the 2 logs. There's a plus sign between them. So that means this and this must have been originally what? What operation? It's split as a plus. Must have been multiplication. So x plus 3 times 2 2 minus x. So those are multiplied together. Equals 1. Now the next step is more of an algebra step. You need to FOIL that out, okay, or distribute it. Right, so we'll distribute everything out here and then see where we go from there. All right, so that's not going to change. And that's not going to change. All right. I'm going to do it off to the side because I'm going to have some like terms, and I want to put the final answer in the steps that I'm showing you. So off to the side, I'll do this. X times 2 is 2x. Brady, what's x times negative x?
Negative squared. Negative x squared.
Yep, negative x squared. I have 3 times 2, which gives me plus 6. And Abby, 3 times negative x.
Negative 3x.
Negative 3x. So here are the like terms I was talking about. I'm going to write it in order like we normally do. So I've got negative x squared, 2x minus 3x. 2 minus 3, that's negative 1x plus 6. All right, so now I've taken my logarithms that were separate and I combine them together. You don't have any numbers in front, so there's nothing to put back as an exponent. So as far as the combining, splitting, and moving numbers back as exponents, all those rules are done. At this point, that's an equation in log form. So what did we learn on Monday we can do with an equation that's written as a log? Yep.
Change it to exponential.
Change it to exponential. That's the only thing that's left to do. Here's your 3 things. 1, all of that is the second thing, and there's the third thing. So Lexi, what's my base there?
4.
4? You got that. Caitlin, what would my exponent be?
1.
1. Logarithm always equals the exponent. So 4 to the first power equals, and now put down what's on the other side. Negative x squared minus x plus 6. Now that's a quadratic equation. Now we just solve it. Okay. Several ways you can solve a quadratic equation. You can factor it. You can use the quadratic formula. You can complete the square. You could use a graphing calculator, but we don't really do that in this class. So we're probably going to stick with either factoring or the quadratic formula. Now, to use the quadratic formula, first thing you want to do, or factor it, either way, you want to get it equal to something. Right now, it's equal to 4, 4 to the first power. We don't want it equal to 4. When you're solving a quadratic, what do you want it equal to? Oh, Sam? Not 1. Sometimes you get things equal to 1. Not in this case, though. Yeah?
0.
0. You want it equal to 0. So one way you could do it is just say, all right, put the 4 on the other side. Well, I'm not going to do it that way. I'm going to do it kind of a long way. I'm going to take everything that's on the right and move it all to the left. The reason is that right there. I don't like having a negative in front of x squared. Okay? That's going to mess it up if we try to factor it. So one easy way to solve that problem is if you move that to the other side and everything else with it, that negative will turn to a positive. So when I do that, I'm going to be left with 0 on the right. I'm going to have to add the x squared. So it's going to become plus. I'm going to add the x to move it. And I'm going to subtract the 6, but I already have a 4 there. So when I subtract the 6 from the 4, what does that leave me with?
Negative 2.
Negative 2 equals 0. All right. So now, if we try to factor that, let's see. We're looking for 2 numbers that multiply to give me 2 and subtract to give me 1. Anyone think of 2 numbers that multiply to give me 2 and subtract to give me 1? Yep.
2.
2 and 1. So my first two terms are x and x. When you have a positive middle and a negative constant, what are your signs in the parentheses? Yep.
Positive 2 and negative 1.
All right, so we need a positive and a negative. And it could be a 2 and a 1 or a 1 and a 2. We'll try it the way Luke said first, a 2 and a 1. So that's, I'm going to check it. X squared minus x plus 2x minus x plus 2 is a plus 1. And then 2 times negative 1 is negative 2. So now we factored it correctly. Now, you're multiplying this times that, and you're getting 0. What's the only way you can multiply two things together and get 0? Yeah.
If 1 is equal to 0.
Yeah, if one or both are equal to 0. So either the first factor has to be 0, or the second factor has to be 0. And now solve each one. So if x is negative 2, that would give you 0 times something, which is 0. Or if x is 1, that would give you 3 times 0, which is also 0. Okay, any questions on those two? Now we're like 99% done. The last thing we have to make sure of is, do both of those answers work? Okay, there's three cases. They either both work, they both don't work, or one works and one doesn't. Okay, so to check if they work, I'm going to go back up to the original problem. I plug them in to the arguments, and I have to make sure the argument never comes out negative. If it comes out negative, we have to cross that answer out. Because if you try to take the log, it doesn't matter that the base is 4, base anything. If you try to take the log of a negative number, you're going to get an error saying that it's imaginary. So let's start with, let's check 1. Jordan, if I plug in 1, what's 1 plus 3?
4.
4. That's positive. I can do that, no problem. What's 2 minus 1?
1.
1. That's positive, no problem. So that answer definitely works. Let's check negative 2. How about Cassandra? What's negative 2 plus 3?
1.
1. That's fine. What's 2 minus minus 2?
4.
4. That's fine. So in this case, both answers work. Okay. Any question on that one? Yep.
When you did that, were you just looking for if they were positive or negative?
Yep. I was just looking if they came out negative.
Okay.
Yep. Because if what I put a box around comes out negative, the answer doesn't work. So let's say you got x equals 5. Okay. When you go to check it, you'd be like, okay, 5 plus 3 is 8. All right. It would work there. Wait a minute. 2 minus 5? That's negative 3. You can't take the log of negative 3. Okay? So if it comes out negative, it doesn't work. Okay. In fact, even if it comes out 0, you can't do that either. It has to come out positive. Okay? Want me to answer?
Want to answer it?
He looks like you already stopped that. So the last step here, check to make sure you are not taking the log of a negative number. It has to be positive. It can't be 0. It's got to be positive. Okay. All right. So now we'll look at a couple easier ones, a couple quick ones, and then we'll look at the one that's the longest one. All right, so this is log base 3 of x equals 9. There's not much there. Okay, you can't combine or split logs because look at it. There's only one log. To combine, you would have had to have 2. Well, there's only one. Are there numbers in front of the log? Nope, so there's nothing to put back as an exponent. So there's no combining, there's no splitting, nothing to put back as an exponent. There's only one thing left you can do with that. Yep.
Change it to exponential.
Change it to exponential and see what happens. Okay. How about, Tanner, what's my base there? 3. And my exponent? 9. And what ends up by itself? The argument ends up alone, and that's it. That's the answer. So that's a quick one. If they ask you to do that out, it's that's going to come out kind of big. I mean, it's not like it's in the trillions, but it's kind of a big number. So it's 19,683. When it gets to a point where it starts getting pretty big, like that's probably big enough that you could just leave your answer 3 to the 9th. Okay. Questions on that one? All right. Let's look at this one. Little different because that was an equation in log form. That's an equation in exponential form. So now, what could I do with that equation? Put it in log form. Okay, that's the only thing you can do. Put it in log form. So let's start with the word log. Alan, what's going to be my base on the log? 2. That's my base there. Okay, and we keep saying this all week. Logarithm always equals what kind of number? Exponent. So the only thing left is what was all by itself up here, and that's your argument. And there we go. So just by doing that, we already have the variable alone. We just have to type this in. Now, does the calculator have a button on it for base 2? No. So we can't type that in. We have to rewrite this in a way we can type it in, and that's the last thing we learned yesterday. So it involves a fraction. And how do I rewrite that so I can type it in? Yep.
Log of 5 over log of 2.
Yep. Log of 5 over log of 2. You could also do ln 5 over ln 2. I showed you yesterday. That's the same thing. And now we just see what it comes out to. Log of 5 divided by log of 2. So if you wanted to raise 2 to a certain power and get 5, well, 2 to the second power is 4. So the second power was too small. 2 cubed, 2 to the third power is 8. Well, now we've gone bigger than 5. So the answer is between 2 and 3. It's specifically 2.32. So if you raise 2 to the 2.32 power, you would get 5. Well, you'd get about 4.99 or something like that, because it's rounded. It's about 2.32. Any questions on that? Yep.
How can we divide it?
Because that's the change of base formula. That's how you have to rewrite this so you can type it in on a calculator. Yep. Now, if you're wondering, like, what would be a problem where you would end up solving for a variable? That's what we're going to see tomorrow. Okay, more of like a banking kind of problem. Like, let's say you put $1,000 in a bank account, and you wanted to know how long is it going to take to earn $50 in interest. Okay, if you don't touch the money, you just let it sit there. You don't add to it. You don't take any money out. It just stays in the bank. How long would it take to make $50 in interest? To solve that question, you would have to use a logarithm. That's the only way to solve it. So that's kind of what tomorrow is. It's looking at different things that are kind of financial based, looking at like interest in a bank account or interest on a mortgage or something like that. Right. But the formulas involve variables in the exponent, so we can use logarithms for them. All right, that's pretty much the same kind of problem as the last one. So, does anyone think they could just, looking at the pattern for the last one, just jump right to that step and tell me what the fraction would be? Simon?
Log of 24 divided by log of 3.
Yeah. You just have to type that in on your calculator. And again, how did we get that? We changed to log form and then used the change of base formula. But it's all laid out right there for you. Okay, so that one's very similar. The next one. Kind of similar, but there's one extra thing. In the previous problem, the base with the exponent was by itself. By itself, by itself. This time it has a times 8 next to it. So how would I get rid of that times 8 and move that to the other side first?
Divided by 8.
Divided by 8. So you always have to get the thing with the variable in this kind of problem. The thing that has the variable as the exponent by itself. Okay. So now you have that, and now it's the same as the last two kinds of problems. It's going to be a log over a log. 3 is your base, so that goes in the bottom. And 5/8, that would be your argument when you rewrite it in log form. Okay, and just to show you how to type in a log with a fraction, you just use the divided by symbol. But it's log of 5/8, close the parentheses, divided by log 3. So you get about negative 0.43. Now, I mentioned earlier that you don't want to take the log of a negative number, and I didn't. 5/8 is a positive fraction. 3 is a positive number. The result came out negative. That's fine, as long as these two numbers are not negative. Okay? So negative 0.43. Okay. Any questions on that one? All right. This one. So what makes this one a little tricky is the bases are different. If the bases were the same, it would be a lot easier, but they're not. So on the left, you have 5 to the power x minus 2. On the right, you have 3 to the 3x plus 2. Every step in this problem you already should know how to do, except maybe the very first one. And actually, even the first step, we did it once this week. We did it yesterday when I was showing you what the change of base formula was. I don't remember exactly what I started out with, but I think it was like we had a y by itself. And we might have had like x to the m. Or no, what was it? No, it was like this, log base x of m. And I said the problem with that is if the base isn't a 10 or an e, we don't know how to type it in. So I came up with a different formula, the change of base formula. But to do that, I changed this to exponential form. That was the first thing I did. And then I did something on both sides. Does anybody remember what I did on both sides at this step that allowed me to put this y in front? I can't put the y in front unless I have something there. Remember? Yep.
A log.
A log. I took the log of both sides. Because if you don't have logs, you can't just move exponents in front. It's like you can't just say that this is the same as this. No. You can't move exponents in front in general. But if you have a log, you can. So I took the log of both sides. And that's the first step on this problem. Take the log of both sides. And then you are going to be allowed to move the exponents in front. Okay. So I'm going to rewrite it a couple times just so you can see every step. But you certainly could combine some steps here. So the log of what's on the left and the log of what's on the right. because you have logs, we can move those exponents in front. So we have x minus 2 times the log of 5. And then we have 3x plus 2 times the log of 3. Any questions on that? Now, the only thing that's going to look confusing here is the fact we're going to have the word log written a bunch of times. Remember, log of 5 is just a number. Okay? I'm not going to write this down, but the log of 5 is just the number 0.7, roughly. So this equation, which again, I'm going to erase in a second, I just want you to see this, is basically like having this. X minus 2 times 0.7 equals 3x plus 2 times, and the log of 3 is about, let's just call it 0.5. Okay, I'm not going to use that because that's rounded pretty bad, but it's about 0.5. So if you can solve that equation I just wrote, that's exactly the same as solving the equation up above. So looking at this one, what would you do on both sides with the 0.7 and the 0.5? And what's next to each one of them? Yeah, you would distribute. Now, I'm not going to write it as 0.7. I'm going to write it as log 5. Okay, but that's all I'm basically going to do. I'm just going to distribute out the number to each x. All right? I'll kind of keep this up here just so you can look at it to see something simpler without the word log, but it's really the same thing. So we have x log 5 minus 2 log 5. Okay, that's the first part. Do it on the second side. 3x log 3. And then do it on the next part. Plus 2 log 3. Now, if I took the word log out of that, it would look very simple. If I just wrote it as like 5x minus 2 times 5 equals 9x plus 2 times 3, it would look a lot simpler. Okay, but we have the word log there, so we're going to make sure we keep it, but don't get confused by the word log. Log is just a number if you were to actually do it out. Okay. So now at this step, you would have something like 0.7x minus 1.4 equals, just trying to do that in my head, 1.5x plus 1. That's basically what you have right now if you were to do this all out. Okay, 2 log 5 is about 1.4 and all that. So now what would be your next step if you were solving this equation? What would you want to do with all your x's? Yeah, combine them. Get them all on the same side. Okay? So we're going to do the same thing here. Let's put all the x's on the same side. So I'm going to minus x log 5 and minus x log 5. Okay? I'm not really going to be able to combine it. I'm just going to write it the way it is. Okay? But there's not really much I can do. Now the next thing. Once I minus the x's, okay, once I've done this and this, that's what I just did in the last step. Now I'm going to put all the numbers on the other side. So let's subtract 2 log 3 and subtract 2 log 3. Okay, I'm going to rewrite what I have right now. But all the x's are going to be on one side, all the logs are going to be on the other. Okay, I need to erase that simpler looking equation because I need some more space. All right, so now we have negative 2 log 5 minus 2 log 3. It'd be nice if we could just combine that, right? We could do this out as a decimal, right? Or we could use our log rules and combine it, but I wouldn't even bother. I would just leave it like that, because in the end, we're going to type it into a calculator. So we don't have to use any more rules than we have to. Okay, and on the other side, we've got 3x log 3. And we subtracted x log 5. Okay, so now we're just about there. We have all the x's on the same side, which is good. But look at these two terms. 3x log 3, x log 5. What do they both have in common in front of the log? They both have an x. Whenever two terms have the same thing in common, we never like to write it twice. We'd rather factor it out and write it once. So that's what I'm going to do. I'm not going to change the left-hand side. And if I was actually doing this problem, I probably would have done this step and the last step at the same time, so I didn't have to rewrite the whole thing again. Okay, but I'm just trying not to leave out any steps. So they both have an x in common, so I'm going to pull that out in front. That would leave me with, if I take the x out of the first one, 3 log 3. And what if you take the x out of the second one? What are you left with? Log 5. Okay. Now we're at our last step. What you have right there is a number. I'm just going to make up a number. -10. Minus a number. Again, that's not what it equals. I'm just making up a number. Equals x times, and that whole thing right there with the logs, that's just another number. Let's pretend that 3 log 3 minus log 5 comes out to 12. That's basically what you have at this step. A number minus a number equals a letter times a number. So the last thing to do is get this number on the other side, and you'll have x by itself. So how would I move the number to the other side? What operation would I use? Division. So divide by the number that's next to x. In this case, it's a 12. In this case, it's whatever this number is. Just divide each side by it. So 3 log 3 minus log 5. And that's our answer for x. So what makes it a little confusing is you've got the word log written 4 times, and you can't really do anything with it till the very end, which is now putting it into the calculator. That's a lot to put into the calculator. If I were you, I would do it in steps. Okay. So what I would do is something like this. Type in -2 log 5. Okay, that's the first part. Minus 2 log 3. Okay. I would just do that first and write that down. So it's -2.352. Divided by, now I would do the bottom. 3 log 3. Make sure you close the parenthesis. Minus log 5. So 0.732. And now I would divide those two. Now, do you have to do it this way? No, you can type the whole thing in at once. But if you're not careful with parentheses or you mess up, it's a lot of symbols you got to keep track of. This is just doing it in stages, so it's a little easier. So -2.352 divided by 0.732. So the answer is about -3.21. Any question on that? So one thing I can do, and this is something we would do in pre-calculus, to check the answer without typing it in, because I don't really feel like doing any more work on this. I can just graph these, and it's going to draw two pictures on the screen, and I can look where they cross. And in theory, they should cross exactly at negative 3.21, if we did it right. So, hope we did it right. So let's just take a look. So we've got 5 raised to the x minus 2. That's going to look something like what you're seeing in blue. And the red one, so these are definitely not straight lines at all. This is not y equals mx plus b. 3 raised to the 3x plus 2. Now it's a little hard to see, but I can kind of try to zoom in a little bit. They're so close together. It looks like they're right on top of each other, but they're a little bit different. My screen, it's not like a super high definition screen on this calculator. So they're so close that it just puts them at the same spot. But I can try to zoom in a little bit. Let's try like negative 0.5 and 0.5. And hopefully you'll see they're not exactly on top of each other now. We'll see. I mean, before it looked like they were on top of each other pretty much the whole time. And, well, they still look very, very close. But they're actually very, very slightly different. Okay, I'll try one more time to show you if they're different. If I can't get it this time, I'm just going to let the calculator tell me where they cross. So let's try negative 0.01 and 0.01. So what I'm playing with is I'm trying to zoom in very, very close to see if they're different. So there's that one. And yeah, they still look like they're really close, but now I can kind of start to see they're crossing a little bit. It's kind of hard to see, but I don't know. Can people see like right there? You can kind of tell that the blue one is actually on top, and then all of a sudden it goes underneath the red one. If I kept zooming in, I could make that even clearer. Okay, but they are starting to cross, and I'm going to let the calculator tell me exactly where they cross. This is kind of the hard thing about using a graphing calculator. You're still going to know how to zoom in a little bit. But the easy thing is the calculator has a feature that's called intersect, and it can tell me exactly where they cross. So I just tell it, all right, find the intersection between the blue curve and the red curve. And it tells me, make it a little bigger, tells me these two intersect at exactly negative 3.21, which is exactly what we got. Okay? So graphing calculator can be a nice way to check your answer quickly if you know how to use it. Okay? You don't have to know how to check your answer. I'm just showing you. All right, this one, I just want to look at it for a second. It's not one we're going to solve. But I want you to notice something that some people try to do right away and you can't do on this one. What do you think some people try to do right away here, but you can't do it because of something? Oh, Casey?
Combine the log.
Yeah. People try to combine the logs right away. And you're like, well, why not? You have a log plus another log. We did one very, very similar to that, right? Right here. We had a log plus a log, and we combine them. Well, in this problem, you can. In this problem, you can't. How come? Yeah.
The bases are different.
The bases are different. And that's all I really wanted to point out in this problem. Okay, I'm not going to solve it. It is still very solvable, but we're not going to solve it. Okay, so here, the logs cannot be combined because the bases are different. Doesn't mean you can't solve it. Yes, you can. You still can solve it, but not quite the way that you would think by combining the logarithms. Okay, so any questions why you can't combine logs there? That's all I want you to understand. All right, let's look at this one. X plus e to the x equals 2. Okay, this is another one that's a little weird. It's got e. We've talked about e. E is just the number 2.718. And the problem with this one is you have an x in an exponent, which if that's all you had, that's not a problem. That's exponential form, change it to log form, and you can solve it. Or if you didn't have an x here, well, that's even easier. E is just the number 2.718. Just subtract 2.718 to the other side and you're done. So if you just had an x in either spot, it's very easy. But you don't. You have it in both. And with algebra, I don't know how to get x by itself there because it's in both spots. So this is not one that's easy to do by hand. This is the kind of problem that if I had to solve it and just get an answer, I would do it on the calculator. I would graph this on one side of the, as one color. Maybe I'd graph that as the red line. I'd graph that as the blue line, and I would look where they cross. That's how I would solve that one if I had to. Okay. I don't know any other way to solve it off the top of my head. I mean, you could always guess an answer and check it. You could try, all right, does 3 work or does 2 work? But it's going to take forever to just guess answers and see if they work. All right. So I would use a graphing calculator. Okay. So any questions on that idea of using the calculator? Drawing 2 things and seeing where they cross each other. This one would be a lot more obvious. I think one of them looks like that. The other one looks like that. So it's very easy to see where these cross. The previous example I gave you, it was kind of hard to see it until you zoom in a lot. And I would have even had to zoom in a little more. But. Any questions on that? All right. That's another example like the one we've done before. So I'm going to skip over this one. I think this is one where when you check the answers, one works, one doesn't. Okay, the one we did earlier, they both worked. Okay, this one works, one doesn't. Okay, but this bases are the same, so you can go about it exactly the way you would think you could. Okay. All right. So, any questions on the problems we did today? All right. So the homework, just a few different examples of the types we did. So 1, 2, 3 all, 5, 6, 9, and 17 through 21 are. So 9 questions. Okay, on page 490. Okay, don't forget, I will be after school for extra help tomorrow. If you have anything you need to make up, tomorrow is the last day after school to make it up. Otherwise, you guys have until Friday for anything else. If it's not done by Friday, then it is a 0. That's it. So come talk to me if you have any questions or concerns about that.